Hello everyone, and welcome. Wait, something doesn't feel right. I know what it is. This isn't how one of these videos is supposed to start. Let's try that again. You'll never guess what I have for you today. Stop even trying. Do you know what this is? This, my codependent friends, is the culmination of over 400 years of blood, sweat, tears, you know, maybe some iron and carbon, in the search for the ultimate material. If you think of this in terms of strength per dollar, nothing comes close. Sure, it costs more than it used to, but strength-wise, it's still orders of magnitude stronger than anything that came before it. In fact, hold on, I'll be right. See this thin wire? I should have thought through this better. I hope you can see that. This is the same stuff. You could hang almost 500 pounds from the end of this. This stuff is strong. 500 pounds. I'm not sure what would happen or if I'd stand under it, but you could hang 500 pounds on the end. When this stuff first hit the streets, it changed everything. 100-story timber frame skyscrapers instantly became a thing of the past. And your sword, it no longer bent like in the cartoons. Unless you're into fencing, I guess. But it changed everything. Get your jaws up off the floor, my friends, because this is steel. And frankly, it's a modern marvel. I'm not just saying that because I saw it on Modern Marvels. Now, most normal people making a video would probably stop right there on the high note, but not me. We're gonna take this a step further and build something with this. What we're actually building isn't important, but in order to build anything at all, except for maybe a pile of metal tubes, we need to join these. So how do you join tubes made out of one of the strongest materials on Earth? We could bolt them together. That's how they did it in the good old days. Bolts or rivets or whatever. Some sort of mechanical fastening. And if my childhood taught me anything, we could also use crazy glue. But if I've got my lathe settings right, we live in an age where welding is a thing. So that's what we'll do. Bolts and rivets still exist, but today we're welding. MIG welding. I suppose that's not terrible, but I think we should be able to do better. Yeah, +5, what the heck. I completely missed half of that weld. If you're wondering, yes, that's extremely hot. And yes, if memory serves, you're not supposed to MIG weld downhill like this. But let's just say I've got my reasons. +5 might have been a little too much for an inside corner like this, but comparing the two, I mean, it does look like a lot less spatter, which is what I'm going for. If I sound different, my apologies. It's the future and I'm still getting over what turned out to be quite the brutal cold. That, and I'm using over 50% of my brain power, telekinetically keeping all this tubing suspended in the air and in position. And here it is, the HTP ProPulse 220 MTS. Now, me and this thing are still getting to know each other. We've recently gotten over the smiling at each other from across the room thing and are now officially holding hands in public. But today, I want to see if I can't get to second base. We're going to try pulsed MIG welding. I mean, I've been playing with it all week, on and off. Still can't quite get it nailed down, but I thought we could go on a romantic journey of exploration together. Wow, did you see that? I certainly hope you did, because I went through a lot of trouble to reposition the camera. That was pulsed MIG welding. Blows my mind. And that's pretty darn clean. Spatter-free, almost. Maybe still a little cold, sure. Like I said, this is really my first try at pulsed MIG welding. But this? I mean, it's not that long ago that doing this kind of thing at home was unheard of. This right here is cutting edge tech. Brand new. Okay, fine. I'm just getting the memo. But you know, pulsed MIG is newish, like in geological terms. Anyway, that seems a little bit cold to me, though the wire speed's up to like 350 or something crazy. Let's try to lengthen the arc, increase the voltage at the machine, and try that again. Same wire speed. This will go to +8. Let's try +2. +1.5. I've got a lot of these welds to do, so plenty of chance to play around. Not much difference, to be honest. I'm still hearing the sputtering, that short circuit transfer sputtering. We'll get to that in a minute. Maybe that's normal. Perhaps my wire speed is still too slow. Again, 350 seems insane to me, but what do I know? I went to the max on the machine for this material thickness. I'm looking at it now, it's 413, and I set the voltage or the trim back down to 0. Seeing that number, instinctually, I think I'm just gonna wanna really book it with this torch. But I'm gonna try to maintain sort of that same travel speed I did at the lower setting. This might be a too smart for my own good kind of a situation. Get all that junk out of there. The wire is trimming off really nice though, nice and clean. No balls or boogers or, yeah, I like that. Here goes nothing. I did exactly what I said I wasn't going to do. You can probably tell I moved too fast through here, realized I was moving too fast, and then slowed the torch down, and things looked better. It feels so unnatural. Counterintuitive. But half of that looks good. I think this is my setting. I've just got to be more consistent with the torch. Looks like I'm still maybe moving the torch a little too fast, but we're getting closer. Well, I'm getting closer anyway. Evidently, I've still got a lot of practice ahead of me. I'm extremely MIG rusty. It's been quite some time since I've MIG welded. And in that time, I've become a TIG snob. Full disclosure, I thought this whole thing was going to be a lot easier. But it looks like there's a lot to relearn. And I guess a lot to unlearn old bad habits. I used to MIG weld the same way I drive my car. Half asleep and weaving a lot. But with these new machines, it's my understanding they might not like weaving. Or don't need to anyway. Probably even more so with this synergic pulse where the machine is making updates 1,000 times a second while you weld. The weaving probably doesn't help the processor that much. I'm not sure. Okay, let's start again. It's a new day, I'm still sick, but I just had another look at those welds and I'm not that impressed. I don't mean to sound harsh, but sometimes the truth hurts. This HTP is synergic. What that means is it's been programmed to be smarter than me. This machine has been jam-packed with the brains of welding engineers and scientists and dirty lab coats, and I think I've got to get out of my own way. Back in the good old days, you'd turn a MIG welder on and set the voltage and wire speed you think you want to weld at. If you have an older MIG welder at home, you probably do the same thing. Set it to some number between A and D or something and pick a wire speed. You might start with a chart, then tune your settings from there until you hear something that puts frying bacon on the table. All of that would be based on what you're trying to weld. Thin stuff, lower voltage and wire speed. Thick stuff, higher voltage, higher wire speed. The chart or experience would be a starting point, and you'd tweak based on, I don't know, the day of the week, the mood you're in. If you're welding a butt joint or a T-joint, the metal might not be as clean as the chart thinks it is. There's a million reasons. On a synergic machine like this one, you kind of do it backwards. Well, in that the chart is built in. With these, you pick your material thickness, and all the smarts packed inside do the rest. I turned the brightness down just so you could see the screen better. Hopefully you can read the screen better. And this machine has a fan that runs all the time, as soon as you turn it on. I mean, it's low. It kicks into high gear once you start welding or if it gets too hot. But I think I'm going to pull a little movie magic, show you the screen, but turn the machine off so I'm not talking over that whoosh. Since we're here, these are the settings I've been welding at. There's 120 thou for 1/8 inch material. The welder set itself to 23.3 volts and 413 inches per minute. That's telling us it's going to be a 118 amp weld. And hopefully you can make out the program across the top. It's MIG, mild steel, 030 wire, and since I'm in Pulse, I'm currently using a 90-10 mix. So it's mostly argon with 10% CO2. Let's say we're doing just regular short circuit MIG. Ignore the Pulse stuff for now. There are other options down here for aluminum, pulsed aluminum, double pulsed aluminum. It does all sorts of crazy stuff. Stainless steel, silicon bronze. You pick the recipe and that's what the machine will cook for you. But let's say you're just doing plain old short circuit MIG. Mild steel, 030 wire. You've got, I don't know, 75-25 mix, an 80-20 mix, your standard stuff for short circuit. You can see it started off like at the minimum thickness, 048 thou, so a little more than a millimeter. Again, that's for 030 wire size. I'm sure if we had a smaller wire size, that might have started at a lower value. So I'll scroll up to 1/8 inch. There's 048 again, 050, 060, 080. Now there's a lot of 120 programs, and then it jumps to 128, I think. There it is, 128. There's only one 128 program, but there's a whole heck of a lot of 120s. Since I'm at 125, 1/8 of an inch, I'm just going to go to the highest one in the 120 menu. And according to the machine, it wants to weld at 511 inches per minute and 22.2 volts for a total of 150 amps almost. Notice we did not pick a voltage or a wire feed speed, only the material thickness. The machine did the rest. And before we go into that pulse welding thing, let's take just a moment to talk about all of those material options. So 120 has 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19,
20. Any less than that and it drops in material thickness. So 20 freaking settings for 120 thou material, for 1/8 inch material. How do we make sense of that? Which of those 20 settings is for us? If I want this thing to make me chocolate chip cookies, I just want it to go. I don't want to have to search through 20 different recipes. I mean, if I knew how to bake, I wouldn't have bought the synergic oven. To understand why this machine is giving us so many options for the same material size, we have to take a moment and talk about apparent thickness. If you're scratching your head thinking apparent thickness, I've never heard of that before, calm down. It's something I just made up for lack of a real name to call it. Check this out. These are pieces of 1/8 inch flat stock, a little more than 3 millimeters. And the welder has 10 different options for this, or 20, whatever it was. Why is that? Well, it depends on how you're going to weld these together. So simple butt weld, but I put them down on this nice thick ice cold workbench. You can bet your bottom dollar this bench is going to suck a lot of heat out of this weld. So this would be a setting, some setting on the welder. I don't know what, but 1 or 2 settings will be correct and the rest won't. So now let's say I do the same butt weld, but now they're up in the air. The heat needed to weld these when they were sitting on the thick bench now might be too hot and burn right through the same exact material thickness, sort of isolated and floating up in the air. I mean, I'm maybe pushing this a little bit, but hopefully you get the idea. Likewise, maybe they're a T-joint or an upside down T-joint. If you're welding them edge to edge, 90 degrees, this vertical piece, assume you're welding straight down into this joint, the vertical piece to the welder appears thicker. You could argue it's almost 1.5 inches thick compared to the 1/8 we have at the top. You'll need less heat in this top 1/8 inch part than you will in this lower 1/8 inch part. In cases like this, your brain will probably take over and you'd bias the puddle to the thicker piece and perhaps just watch it wash onto the thinner piece. This might look more like this. Or you might go slower with the torch or faster. There are other variables at play. This is a tangent on a tangent, I know, but this concept of apparent thickness comes up all the time. If you're stick welding really thin material, probably thinner than 1/8, and you point that electrode right straight into the surface, it's pretty easy to blow right through. But if you angle your electrode, usually pretty steep, the material sort of acts like it's thicker. The bead that you're leaving behind plus that angle that you're pointing at has less of a downward component, less of a downward force, and it's easier to make those thin welds. Same thing if you're flame cutting. Say this is my oxy torch or plasma cutter. You don't have to take my word for it, you can go ahead and try this. If you're cutting real thin sheet, you'll likely blow right through it again and lose your cut. Have to start over and over. Sure, you'll get through the material, but do that enough times it'll look like your dog chewed through it instead of it being flame cut. But if you angle your torch, your cut won't go out as easy and you might end up with a nice clean cut line. It's as if the material appears thicker to the torch or the electrode. Same thing here with the MIG welder. The joints are all 1/8 inch material, but require completely different settings. Well, maybe not completely, but different enough to make for a good or a bad time. And that's why the HTP gives us as many options as it does. In all fairness, it's not like the HTP can see what we're doing. Some of this has to be on us. Now this might very well be the breakfast beer talking, and I hate to blow your mind so early in the morning, but I have a feeling that that material thickness that's showing us doesn't actually mean anything at all. I don't think it cares how thick our material is. I bet the machine is just following some curve programmed into its brain box that makes a correlation between wire speed and voltage. And it dims the display when it doesn't like what it's hearing. For the wire speed we told it we're using, 030 in this case, and the gas mix, HTP has given us some combination of voltage and wire feed that should result in stable metal transfer from the wire we're unrolling to the metal we're caking it down onto. If you don't like it doing the thinking for you, you can put this into manual mode. If I can figure this out. There it is. Now we're back to the good old days, where we just tell it voltage and wire feed. It's just like your old MIG welder. One knob does the inches per minute in wire feed, and the other one sets the voltage. The synergic light is out, and it's not making any guesses as to what the heck is going to happen. But in this mode, there's nothing stopping you from setting the voltage so high or the wire speed so low that when you pull the trigger, you don't just get a flash and burn your wire back into your nozzle, completely ruining you and everyone else's day. Way to let the team down. So, pulse welding. What's all the hubbub about, and why should we care? You know, it's saying things like that 20 minutes into a video that make me wonder if I'm not making this video completely backwards. Though I suppose better late than never. Word on the street, there are 3 main advantages to pulse welding. First, you can weld faster. But why are you in such a rush anyway? Take the time to smell those welding fumes. Second, maybe more important, you can weld hotter. A lot hotter, I think, than you can weld with regular short circuit MIG. As hot as you can get away with without burning through or losing control, that's the name of the game. Hotter weld probably means better penetration. Less chance your stuff will come unglued. Third, even though it's hotter, because it's pulsing, you can weld out of position. You're in spray transfer mode, which I know we haven't talked about. But in that mode, you really can't weld anything other than flat. Because of the heat and the wire speed, everything is so darned runny. Pulse welding lets you weld in spray transfer mode at those higher currents in any position. Up, down, upside down, inside out. And finally, the fourth of my 3 reasons, very little spatter. And frankly, that's really why I've gathered you all here today. In theory, it's just a whole lot cleaner, or has the potential to be if you get the settings right. Let me show you something. This is a TIG weld. Vertical up, also pulsed. Neither of those really matter, but that is very strong. I know that because I sunk each and every one of those individual beads one at a time. I saw them tie in. Yes, it's slow, but look how clean that is. I'm not talking about whether the weld is pretty or not. I'm talking general cleanliness of the weld zone. 0 spatter, and requires 0 cleanup. I mean, maybe a wipe down with some acetone prior to painting, but that's it. Welded and ready to go. With MIG welding, that's not always the case. This isn't actually a good example. There's not very much spatter here. Let me move the camera. I think this may have been one of the earlier welds I did when I first put the machine in the pulse. As MIG welding goes, this isn't very terrible, but maybe you can see all that spatter still stuck to the steel. This doesn't exactly come right off and will need to be cleaned up. Some might recall I bought this machine for some railings that I made. Although the actual welding there went a lot faster, way faster than I could have tigged the whole thing together, the cleanup afterwards was awful. I had to go over every single one of those 400,000 pickets, or ballisters, whatever they're called, with a cold chisel and knock off all of those little spatter boogers, those little balls. Some of these can be sharp and dangerous, and you certainly wouldn't want them on something like a handrail. Heck, I remember 1 or 2 of them were so bad I even needed to get the grinder out. Usually, a quick shot with a cold chisel cleans them right up. Wow, that looks even worse now. Back when I was doing the hand railings, I didn't have the gas mix to put this into pulse welding mode. To be honest, I hadn't even thought about it. When I got the machine knowing it had pulse, I was mostly thinking about MIG welding aluminum. But I've got 8 of these to make, well, 7 more of these to make, and I want to do everything I can to get them as clean as possible right off the bench. Figuring out this no spatter, little spatter pulse thing now, I think should pay dividends when everything is said and done, and I just need to wipe them down and paint them. We've come a long way, my friends. What do you say we wrap this up? I've still got a ton of work ahead of me that won't get done any faster with me flapping my gums. Before that though, quick recap. You know, like lessons learned maybe. In no particular order, keep your torch clean, like your nozzle clean, and don't bang it around to clean it. I broke a diffuser, I guess. Luckily the kit had a second one, but keep your torch and nozzle clean. This pulse welding seems to be super sensitive to wire feed. Speaking of which, check your wire tension, like the tension rollers inside the machine. There are a million videos online on how to do that. Probably. I've always just pointed my torch at the side of my bench, without the ground clamp attached of course, and adjust the tension on the feed rollers so they just start to move sort of the weight of the torch in your hand. I don't want the wire to slip, but you also don't want excessive tension wearing your rollers out. I've also been trying to keep my torch lead as straight as possible. Like as you're moving around and working, try to avoid any loops or kinks as much as possible. Not 100% sure how much of a difference that makes, but watch the arc closely while you're welding. If you see the arc length, like the distance from the wire to your puddle, if you see that change a lot, longer than shorter or just generally unstable, it might be a wire feed issue. In fact, I think I'm still dealing with that. I still hear it sputtering when I'm pulse welding. I don't know if it should do that. I don't think it should. And occasionally I think I see this wire nosedive right into the puddle. That, by the way, is where all that spatter can come from. But it feels to me like a wire tension issue, so I'm still working on it. Speaking of consistent arc, pulse welding seems a lot more sensitive to grounding, or maybe I guess just MIG welding in general. I started off like you do, just grounding to the bench with the work on top of the bench. I've since moved to grounding straight to the work itself. And really, I mean, would it kill you to clean your ground clamp every now and again? Make sure, of course, you have the right gas mix for your welder. I mean, that's just good life advice in general. I don't know if they're all the same or not, but this HTP wants mostly argon with 8 to 10% CO2 mixed in. If you look close, it says it right on the screen. Pick the program you want, see which mix it recommends, or is required. I'm currently using a 90-10 mix. I have no grounds for this, but I have a feeling that 92-8 might be better. But I can tell you it won't work very well with your standard short circuit 75-20 or even 80-20. If it did, I'm sure they'd list it on the machine. If you're curious, I ended up with the 128 setting, even though my tubing physically measures closer to 120. The voltage adjustment definitely makes a difference. We didn't really talk about this, but you can adjust the voltage. You can sort of tweak it above or below what it's recommending. You can see the voltage there maybe turned red. It's because you're not at the recommended setting. And there it's black. It wants to use 23.4 volts. I tried it and just landed on plus 0.3. If you add voltage, you get a longer and wider arc. Maybe you can make out the graphic there. Next to the voltage setting, there's a little dimension icon, I guess trying to show you the arc length. This will change the arc length. So more positive makes it longer and wider. It's more spray, sort of hisses more. If you take voltage away, you'll get a shorter, tighter arc. Technically better for inside corners, but I didn't like how it was looking, so I settled on plus 0.3. I don't know if I could really tell the difference between plus 0.2 or plus 0.4, but plus 0.5 seemed like too much, and 0.3 seemed to work better than no offset at all. Oh, and here's one I wish I would have known sooner. I was surprised to learn that this pulse welding seems to work better with a slightly longer arc. Or rather, tip distance, not arc. Seems to work better with a slightly longer than you'd expect tip distance. If you typically MIG weld with, I don't know, a 1/4 inch gap, try making it a little bit bigger. Try keeping this gap a little bit longer. 3/8 inch maybe, perhaps more. Give it a try and see what you think. I'm sure there are other things I missed, but this video is getting way too long. Before signing off though, let me tell you about a couple of things I don't like. Actually, it's really just one thing maybe. MIG is freaking dirty compared to TIG. Not as bad as plasma cutting, but definitely worse than TIG. I knew it was dirty going in. I guess it's the deal you make with the devil for welding faster. But holy moly, 6 inches of weld and this place has smoke billowing out the windows. You need good ventilation. And what I need is some sort of fume extractor if I'm going to keep this up. I thought I had my bases covered with the air freshener, but I'm going through like a can an hour, and although I guess it does smell like a crisp spring morning down by the creek, I don't really think it's doing that much. I'm still blowing black soot out my nose for days after a morning of welding. That might also have something to do with all the grinding I'm doing, but any way you cut it, if you're thinking of getting into MIG, put some money aside for a box fan or something. Speaking of box fans, that reminds me of complaint number 2, and this is certainly more my fault. But with MIG, and again, maybe this is just me, the temptation to just tack or make short welds without putting on all your gear is very strong and very dangerous. Just the other day, I was welding with my eyes closed and no gloves and managed to weld a test piece to my hand. Oh, crap. Again, totally my fault, but it's so easy to just one tack and move on. With TIG, that's just next to impossible. I suppose it's cheap insurance for dummies like me. Moral of the story, wear all your gear, long sleeve shirts, and crack some windows open for crying out loud. As far as the HTP goes though, zero complaints. It's a lot more welder than I am. I can tell you it lives up to its name. Despite having a workbench that's as crooked as a politician, just check that frame out. Hecka totally planer. I still have a ton to learn, but it's been a great addition. It would be nice if it had like a wire retract button for when you're setting up, but splitting hairs maybe. The interface is very easy to use, not cryptic, all the information's right there. And I'm sure we'll see this thing again soon, as I'd really like to see how it does with welding aluminum. Last time I tried to MIG weld aluminum was probably 15 years ago, and you needed to jump through so many hoops. Special cable liners, your welder had to be higher than your work, you had to keep the lead pulled straight and taut as a violin string, and even then you could only weld 2 inches before having to stop and clean a pound of bird-nested wire out of the feed rollers. I'm curious to see how this does in comparison. But anyway, as always, I very much appreciate your company, and thanks for watching.